Hello everyone, so today we are going to start a new chapter that is called the application of differentiation. So if you don't know how to differentiate any function, you can go to the playlist of my channel and you will find a differentiation chapter and you can complete the chapter and you can come back again, because here we need a differentiation. So the first application of the differentiation which we are going to do is the tangent to a curve. Okay, so before I start, if you haven't subscribed my channel, please do, because then you will get updated with the more tutorial in the future. And let's start the chapter. Okay, so now here we are going to do the equation of a tangent to a curve. And let me tell you what is a tangent. Tangent is nothing, it's just a straight line touching a curve. Okay, so let's say you have a curve, you have a point here, and this line is touching the curve. So that is, this line is called tangent to this curve. Okay, there can be many tangent to a curve, because if I will take this point, there will be one tangent here. If I will take this point, there will be another tangent. Okay, so the tangent are a line which touches the curve at only one point. You can see that these lines, this is not good drawing, so but this line will only touch this curve at only one point. So tangent is a straight line. Okay, so from our coordinate geometry we know that to find the equation of any line, you must know its slope. Okay, and you must also know a point, okay, where it through which the line passes. Suppose if we have a straight line like this, you need a point. So if you know the slope and you know the point x1 comma y1, then you can form the equation of tangent or equation of line, which is y comma y1 is equal to m x comma x1. So these y and x are variables, and x1 y1 and x1 are the point, and you have the slope. So you can form the equation of the line. So to find the tangent to a curve, you need a slope, and we know that from our differentiation chapter. We know that differentiation is the slope calculation at certain point. Okay, so if any function is given, you can find its derivative, or you can find differentiation of that function, and you can put the value x1 here on y1. If there is a y1 also, you will get the slope. So first we have to evaluate the slope of the tangent, that we will get by finding the differentiation and putting the coordinates or the point, and then we have to find the equation of the tangent by putting the slope and the point given. Okay, so this is the way you can find equation of any tangent to a curve. Okay, in some case the function will be given, the slope will be given, and the only one point will be given. So in that case you have to find the next point y1. So to find that, you have to just put x1 into the function and you will get its y1 value. Okay, so now let's start with the question. So the first question is, find the equation of tangent to a curve y is equal to 3 plus sine x at point 0 comma 3. So we have to solve this question. Okay, now what is given? The point x1 and y1 is given, so I will write x1 and y1 is given, which is 0 comma 3. Okay, now the equation is given, y is equal to 3 plus sine x. Okay, and we want to find the equation of tangent. So tangent is a straight line, so we need a slope and we need a point. So first point is given, and the only we need is a slope. So I can find the slope, which is dy by dx, which is equal to 0 plus cos x. Okay, and remember we are finding the tangent at this point, so you can replace x here by 0. So if you replace dy by dx at x is equal to 0, you will get the slope 1. You can put into this equation 0, cos 0 is 1. So now you also know the slope. So how to find the equation of the line? What you can do, you can use y minus y1 is equal to m x minus x1. Okay, so let's put everything here. Your y1 is 3, so y minus 3 is equal to, slope is 1 and x is variable and x1 is 0. So if you rearrange this, you will get x. So your equation is x plus 3, or you can write in the general term, which is x plus minus y plus 3 is equal to 0. So this is more preferred form because they want your answer in the general form, and this is the form y equal to mx plus c. So this is the answer of this question. So what we have done here is, we had the point and we had the equation of the curve. So what I did is, basically I differentiated and put the value x is equal to 0. I got my slope, and then I have used the equation of line to find the equation of tangent. Okay, so hope that's clear to you. Now we will jump to another question. Here, sorry, this one is slope. Okay, the slope of tangent to the curve is 21 at the point 2 comma 14. Okay, on the curve. Find the value of a and the value of b. Okay, so here slope is given, which means your dy by dx, because we know that slope is your dy by dx, and that is equal to 21. Okay, now what was the equation? Equation was ax cube plus bx plus 4. Now if you try to find dy by dx of this equation, what you will get? You will get 3x square a, okay, or you can write 3a x square, that is also fine, plus b plus 0. Okay, this is dy by dx, and that should be equal to 21. So can I equate this equal to a plus b is equal to 21? Okay, find the value of a and b. Okay, so now this is one of the equation. Okay, so now we have to find the value of a and b, but let's say this is the curve and this is the point. Okay, and this is the tangent. Okay, so we know the slope, and slope at this point is 3x square plus b. So if we have to put 2 here, 2 comma 14, and this will satisfy this equation. This should satisfy, because the slope we have found at this point. So can I write 21 is equal to 3 2 comma 2a plus b, and if you solve this, you will get 21. This will be your 4, so 12 a plus b. This is your first equation. Okay, now this is the curve, and this point is on the curve. So if I will put this into this equation, it should also satisfy. Okay, so let's do that. You understand that why I'm putting this point in the, we can put this point in this curve because this point is on the curve. So let's write that also. So y is equal to 14 plus a 2 cube plus b times 2 plus 4. Let's solve this one. 14 is equal to 8a plus 2b plus 4. Okay, or I can write, I will bring this 4 here, so it will become 10 is equal to 8a plus 2b. Okay, 8a plus 2b. Okay, so let's write 10 is equal to 8a plus 2b. Okay, and multiply the first, or what you can do, divide the second one by 2, so you will get 5 is equal to 4a plus b, and this equation is 21. I'm going to write that here, 12a plus b. So subtract them, both of them. If you subtract, the sign will change, this will be cancelled out, and here you will get minus 8a is equal to minus 16. Okay, hope you understand this one. Now if we'll solve this from here, a will be equal to minus 16 over minus 8 and minus 8, that will give you a equal to 2. If a is equal to 2, then what you can do, you can put in any of the equation whichever you like. So what I will do, I will put into this equation because it's easier one. So 5 is equal to 8 because 4 times 2 is equal to 8 plus b. So and now your b is equal to minus 3. So we have got the value of a and b both. So what we did is, here the slope was given, the point was given, so we calculated dy by dx and we got this one, and we put this point and got one equation, and then we put this one into original equation and we got another equation, and we solved them simultaneously. Okay, so this is the way if the question is vice versa, like slope is given and point is given and equation is given in this form. Okay, so hope you understand this question also. Now let's move to a final question. The slope of the tangent to the curve at the point 1 comma q is 6. Okay, so slope is given, so m is given, which means dy by dx is given, which is 6, and this is happening at the point 1 comma q. Okay, now find the value of p and q. So what I will do, the slope is given, so I will differentiate it. So dy over dx is equal to 2xp. Okay, so this slope was at the point 1 comma q. So if you put this one, you will get dy by dx. So I'm going to put it here, and your dy by dx will be 2p because your x was 1. This is your 2p, and 2p is equal to 6 because the slope is 6. So p is equal to 3. Now you know the p, and now we have to find q. So how we can find the q? Let's see that. Now if you put this 1 into this equation, you should get your y as q. So can we write q is equal to p plus 1? This is another equation, and now you can put p is equal to 3 here, so your q is equal to 4. So that is the way we have to solve this question. Okay, so now I'm going to summarize what we have done so far. So we have the function, we differentiated, we got the slope. Okay, if the point is given, you can put into that differentiation and you will get a value of slope. Okay, so this is the way we have to find a tangent to any curve. Tangent to any curve is just a straight line which is passing through a single point. Okay, if the point is given, if the slope you can calculate it, you can find the equation of tangent. So this is the way you have to solve the problem like this, and I will see you in the next tutorial. And if you haven't subscribed my channel, please do and hit the like button if you like this tutorial, and I will see you in the next time. Bye.